Someone walks up to you on the street and says, 2,943. Quick, is this divisible by 9? It's a matter of life and death. And you could say, well, I can do this fairly quickly. To figure out whether it's divisible by 9, I just have to add up the digits and figure out if the sum of the digits is a multiple of 9, or whether it's divisible by 9. So let's do that. 2 plus 9 plus 4 plus 3. 2 plus 9 is 11. 11 plus 4 is 15. 15 plus 3 is 18. And 18 is definitely divisible by 9. So this is going to be divisible by 9. And even if you are unsure whether 18 is divisible by 9, you can apply the same rule again. 1 plus 8 is equal to 9. So that's definitely divisible by 9. And so the person can go save their lives, or whoever's life they were trying to save, with that information. But this might leave you thinking, well, that was nice and useful, but why did that work? Does this work for all numbers? Does it only work for 9? I don't think this works for 8 or 7 or 11 or 17. Why does it work for 9? And it actually also works for 3, and we'll think about that in a future video. And to realize that, we just have to rewrite 2,943. So the 2 in 2,943, it's in the thousands place. So we can literally rewrite it as 2 times 1,000. The 9 is in the hundreds place, so we can literally write it as 9 times 100. The 4 is in the tens place, so it's literally the same thing as 4 times 10. And then finally we have our 3 in the ones place. We could write it as 3 times 1, or just 3. This is literally 2,940 and 3. 2,943. But now we can rewrite each of these things, this 1,000, this 100, this 10, as the sum of 1 plus something that is divisible by 9. So 1,000 I can rewrite as 1 plus 999. 1 plus 999. I can rewrite 100 as 1 plus 99. 1 plus 99. I can rewrite 10 as 1 plus 9. And so 2 times 1,000 is the same thing as 2 times 1 plus 999. 9 times 100 is the same thing as 9 times 1 plus 99. 4 times 10 is the same thing as 4 times 1 plus 9. And then I have this plus 3 over here. But now I can distribute. I can say, well, this over here is the same thing as 2 times 1, which is just 2, plus 2 times 999. This thing right over here is the same thing as 9 times 1. Just to be clear what I'm doing, I'm distributing the 2 on that over the first parentheses, these first two terms. Then the 9 I'm going to distribute again. So it's going to be 9 times 1, plus 9 times 99. Plus 9 times 99. And then over here, I forgot the plus sign right over here, I'm going to distribute the 4 times 1, so plus 4, and then 4 times 9, so plus 4 times 9. And then finally I have this positive 3, or plus 3 right over here. Now I'm just going to rearrange this addition. So I'm going to take all the terms where I'm multiplying by 999, and I'm going to do that in orange. So I'm going to take this term, and this term right over here. And so I have 2 times 999, that's that there, plus 9 times 99, plus 4 times 9, plus 4 times 9. So that's those three terms. And then I have plus 2, plus 9, plus 9, plus 4, and plus 3. Plus 3. And this is interesting. This is just the sum of our digits. This is just what we did up here. And you might see where all of this is going. This orange stuff here, is this divisible by 9? Well, definitely. 999, that's divisible by 9. So anything that's multiplying by it is divisible by 9. So this is divisible by 9. This is definitely divisible by 9. 99, regardless of whether it was being multiplied by 9. Whatever is multiplying 99 is going to be divisible by 9, because 99 is divisible by 9. So this works out. And same thing over here. You're always going to be multiplying by a multiple of 9. So all of this business right over here is definitely going to be divisible by 9. And so in order for the whole thing, and all I did is I rewrote 2,943 like this right over here. In order for the whole thing to be divisible by 9, this part definitely is divisible by 9. In order for the whole thing the rest of this sum has to be divisible by 9 as well. So in order for this whole thing, all of this has to be divisible by 9.